Okay, welcome back for one more, at least on the first semester Essential Skills Quiz model. I'm Mr. Steele. Once again, I'm going to be working through one of these problem types that you're going to face on your Essential Skills Quiz in the first half of your Math 3 course. In this one, we're going to focus on solving systems, but not solving systems that are linear, but systems that are actually quadratic, that will involve one linear function and one quadratic function, which means solving could be a little bit tough, except we're going to focus on graphing. So we're actually going to graph a parabola, graph a line, find where those two things intersect, and just sort of reinforce both of those skills. Now, if you're like me and you're thinking, well, shoot, didn't we just graph parabolas on question number 5? You would be correct, but these parabolas are not provided in what's known as standard form. They're provided in vertex form. So there's a little bit of an extra challenge in here, something else that's kind of different happening. So you'll get a little bit of a fresh sort of look at graphing some parabolas. Without further ado, rather than keep talking, let's jump in. So our first one here, the instructions are the same on all 3 questions, obviously. We're told to solve the system by graphing. So this is expected, even if you could solve it some other way, you're expected to solve the system by graphing. And we're going to be asked to state our solutions as ordered pairs. So basically at the end of the day, we should have points. And I did say points, plural, because we should get 2 solutions for most of these situations. It is possible there could be just one, but I'm not sure we're going to run into one of those here. It actually requires some pretty precise, situations to be able to make that happen. So in any event, we have 2 things to focus on here. We have our parabola. So there's our parabola right up here that we're going to be looking at and having to do some work for. And then in addition, we also have our line. So what I'm going to do is I'm going to start with the line. I'm much more comfortable graphing lines. I think most of you probably are, just because you've been doing that a little bit longer. So let's start there. The only thing I have to point out is that this line is provided to us in what's known as point-slope form. In other words, this is in our classic mx plus b form. This is going to give us a point to sort of like, one point on an infinite number that are on our line, but we'll have a single point, and then we'll also have its slope, which I know many of you think of as the letter m, but we'll just call it slope for now. So basically, where do we find those 2 things in order to sort of sketch out this line so we've got some good context for what's here? Well, first of all, our point is going to be what makes each side of this point-slope equation equal to 0. So for instance, on the right side, we have x minus 3. That means we're going to need the x-coordinate of 3. On the left side, we have y plus 1. That's going to require y equals negative 1. So that's going to give us a little bit of context here. We're going to have the point 3 comma negative 1 automatically provided. Now the slope is the other piece. That's always going to be the coefficient of x, and where we're going to find that slope is going to be the number that's multiplied by x. And in this case, it's going to be the number that's multiplied in front of the x in that x minus 3. So in our case, it doesn't say the full number, it just gives us a negative sign, but we know to read that as a slope of negative 1. So that means we're going to have our line getting smaller, or decreasing, however you want to think about it. It's got a negative slope, and it's going to have a point, or its slope is going to be up 1, back 1, up 1, back 1, or over 1, down 1, however you want to think about it. So what I want to do is, because I don't know where all these points are going to be, I want to put a bunch of points in here, just so that way we've got a bunch of spots, because we can expect these problems have been written pretty purposefully, so that they're going to have nice intersection points. So let's make sure that we are prepared for as many of those intersection points as possible. And I actually texted Ms. Nakamura last night to confirm how she wanted these problems to be approached, and this was something she mentioned, was plot a lot more points. Plus, it's kind of actually sort of fun to plot points. So there we go. There is our stuff, and I did a horrible, horrible line. Let's see if I can do a little bit better. I think I'm just going to have to stop partway through. So something that you'll learn about me if you watch a lot of these videos is I am not good at drawing lines on here. It has to do with the fact that the system I use is a little bit distorted. I don't know if that word makes sense, but basically it's a little bit hard to control the old school pen on here. I don't have a fancy iPad or anything. But there's our line. So we've graphed our line. Cool, cool, cool. The next thing we need, though, is, of course, the parabola. That's going to show us exactly where these things intersect. So to deal with our parabola, we need to first find the vertex. And the good news for us is the vertex is also pretty easy to find. So in this case, as I mentioned, this is a different form. This is going to be what we call vertex form. And the vertex form of a parabola looks like this. A times x minus h squared plus k. And what that's going to do is it's going to give us automatically our vertex. And our vertex is going to be whatever makes the x portion equal to 0. So in this case, that'll be h. Sorry, that looked like a different letter. and then k on the outside. Because obviously if you plug h in on the inside, you're going to get 0 plus k is k. So in other words, based on this, we can look at our quadratic equation up there. We're going to see that our vertex will be whatever makes x plus 2 equal 0, which is going to be negative 2. And then the y value will be the remaining piece on the outside, the positive 6. So basically our vertex is going to be negative 2, 1, 2, 3, 4, 5, 6. So there is our vertex. So classic starting point. Now our next bit that we need to hit is of course our direction. Again, I'm just following the pieces that we used on our last video about just graphing parabolas. Our direction's all based on the a value, and based on what you just saw up here, we can see automatically that a is equal to negative 1. I will write that down over here, sorry. A is equal to negative 1, and since negative 1 is less than 0 or negative, we're going to have a parabola that opens downward. So we're going to end up with a parabola that looks like that. Of course, we need to find the exact places where it's going to intersect, but you get the idea. So with that said, all that's left is for us to make a quick little table of values. And we're not going to need to do all 5 points here. At least that's my understanding of the question. We aren't going to need to do all 5, because once we find the intersection points, we'll be complete. There can never be more than 2 intersection points. So once we identify them, we should be okay. And let's be smart over here. It looks like on the left side, we're going to intersect pretty fast. So let's go just like we always would. Let's go 1 unit to the right and left of our vertex's x value in order to calculate this. And of course, what we're going to be plugging into, sorry, I should have said that as well, is negative quantity x plus 2 squared plus 6. So let's plug in. So our vertex is at negative 2. Let's plug in negative 3 and negative 1 first. So if we plug in negative 3, we're going to get y equals negative something squared plus 6. So negative 3 plus 2 is going to be negative 1. That's going to give us negative 1, because negative 1 squared is 1. So negative times 1 is negative 1 plus 6, which is 5. And then if we plug in negative 1 here, you might be able to remember that stuff that we talked about with symmetry. But negative 1 plus 2 is going to be positive 1 squared plus 6. But we still have that negative out in front. So we'll still have negative 1 plus 6, which is 5. So our first 2 points here are going to be negative 3, 5, and negative 1, 5. So based on that, we'll see right off the bat that we do get an intersection at negative 3, 5, but we don't at negative 1, 5. So cool, we found one solution point. In fact, I'm going to write that over here. So for our solution, we were looking for ordered pairs. So our first solution we just found, it's going to be the point negative 3, 5. For our second one, of course, we just need to do a little bit of extra work here. We need to go once more. But here's the thing. I'm going to be smart about this. I know that the intersection point isn't going to be on that left side, so I'm going to do a number on the right. In particular, I'm going to choose 0, because that's one more unit away. So if I plug in 0, I'm going to get negative 0 plus 2, or 2 squared plus 6. From here, that's going to be negative 4 plus 6, which is 2. So we're going to get the point 0, 2. That falls right here, which is also going to be on the line. So we've actually found our second solution point, 0, 2. Pretty big outcome. We found our 2 solutions. Now, if you're like me, though, and you just feel weird, obviously we need to finish this parabola, so it's totally sketched. But at the same time, let's use symmetry here. If 0, 2 is on the graph, we're also going to have 4, 2 on the graph, just based on the symmetry around what we call the axis of symmetry. So from here, I can go ahead and sketch in the parabola. But we already did the heavy lifting and found that point of intersection. So there is our first of these problems solved. We had a negative parabola, or a sad parabola. We had a line with negative slope. We were able to find their intersections. It takes a little bit of work, of course, and we do expect you to graph the full thing. But again, we're able to find our solutions pretty precisely, which is nice, not going to lie. That's going to take us to 6b, which is asking us to do the same thing. We just have some more interesting equations to look at. Just like before, I want to start in the same place. I'm going to start with the line. And remember, the line is the one that's to degree 1. The parabola would be degree 2. So for our line, we're going to first identify the point and the slope. So just like we did before, this equation is provided to us in point-slope form. And by the way, I didn't mention that before, but point-slope form is going to be of this form: y minus y1 equals m times x minus x1, And that's where we draw our slope and then our ordered pair out of this, whatever's being subtracted, and then the slope itself. So looking up here, we can see pretty quickly the slope is going to be m equals 2, if you want to call it 2, or m. And then for our point, it's going to be whatever makes each side equal to 0. I think pretty clearly it's going to be 5 comma negative 4. So looking over here, let's graph that. So there's 5 comma negative 4. There is our piece, or there's our first point. Now our slope is 2. Let me remind you that's the same thing as up 2 over 1. So up 2 over 1, I'm going to plot a bunch of points. As I mentioned in the last video, that's one of Ms. Nakamura's biggest recommendations, is graph lots of points. And to be fair, who doesn't love drawing little circles on grid lines? I mean, I'm a fan. I'm sure you are as well. Let's see if I can draw a decent line here. I cannot. I'm terrible at drawing lines, but you can always cover for that by making your dots bigger. Life pro tip, math pro tip. So there's our line. Once again, we've got that handled really nicely. Of course, the other thing we need to talk about is that parabola up there. Once again, that parabola is provided to us in vertex form, and we're going to take advantage of that. So first, we need to know where is that vertex. In this case, it's always going to be a high or a low point. Our vertex is going to be what makes the inside 0, and then whatever the outside number is. So in this case, our vertex is going to be positive 5, comma negative 7. I can go ahead and plot that down here. So 4, 5. There's 4, 5, 6, 7. So there is our vertex. There we go. And now a couple other things to note. First of all, our direction. So will it open upward or downward? That's going to depend on the a value. Our a value would be right here. There's nothing there, so it's going to be a positive 1. And since 1 is greater than 0, this is going to be a happy or opening upward parabola. So we've got that piece. So we know it's going to look like that. We just don't know where exactly the intersections are going to happen, you know? So to find those, we're going to create a quick little table of values. And I think if we're smart, we can use symmetry to our advantage here. You know, we're going to take advantage of the fact that the parabolas do have a symmetry about their axis of symmetry, or about the line through the vertex. So let's think about this. Obviously, we're going to be plugging into y equals x minus 5 squared minus 7. We want to pick numbers that are close to the vertex. So I'm going to choose first x equals 4 and x equals 6. Based on the fact that they're each 1 unit away from the vertex, we should expect to have the same y value. We'll just confirm that's true here, because again, I'm being really careful when I make these videos. I'm not doing them as I would do it myself if I was taking the same quiz. So let's see, if we plug in 4, we're going to get y equals 4 minus 5 is negative 1 squared minus 7. That's going to be 1 minus 7, or negative 6. So we're going to have the point 4 comma negative 6. Notice 4 comma negative 6 lines up really nicely with one of our points. So we've already found our first intersection point. Over here, if we write in an area for our solutions, we've got numero uno, which is going to be 4 comma negative 6. For our second one, well, we got a little more work to do. We know it's not going to be 6, but let's just confirm this is working. 6 minus 5 is 1 squared minus 7, which is, of course, 1 minus 7, or negative 6. So we do also have the point 6 comma 6, or 6 comma negative 6, pardon. There it is. So there's going to be our next point. Once again, we've got that nice symmetry sitting there. It's always helpful to have. Now for our next one, I want to go one more point away. So we're going to choose, of course, 3 and 7. That way we're one more unit in each direction. I can tell it's not going to intersect at 3. Like, that just isn't going to happen, we can tell. But at the same time, we can go over here and actually like take a look and see where it's going to actually pop over. So if we plug in 3, we're going to get the same value as if we plug in 7. So let's do this. Let's not plug in 3. Let's just plug in 7, and then we'll use symmetry to put out the other point. So if we plug in 7, we're going to get y equals 7 minus 5 squared minus 7. That's going to be 2 squared, or 4 minus 7, which is negative 3. So based on this, if we go ahead and plot over at 7 comma negative 3, we're going to end up right there. Unfortunately, it doesn't intersect, which, you know, not ideal, but that's okay. More importantly, though, it also gives us our point on the other side. We now have that other spot. So we're using symmetry to avoid having to do a bunch of extra computation. In fact, I'm going to get rid of that 3 and just pop it right up there. So there is our point. That's great. Like we didn't find another intersection, but you know, we've got another shot. Let's do it one more time. I'll even switch colors for this. So we did 7 before. We know it shouldn't be at 2 because we're getting further away from the line. So let's think it might be at 8. So what do we get if we plug in 8? That's going to be 8 minus 5, or 3. So 8 minus 5 is equal to 3. So 3 squared minus 7. That's going to be 9 minus 7, which is equal to positive 2. So we're going to have a point at 8, 2. We'll also have a symmetric point on the other side, but we'll go with this for now. 8, 2, 1, 2. Oh, look at that. There is our intersection. And of course, there's another one over here. It just doesn't help us with the solving part. But basically, we have now found our second point. They crossed at 8, 2. There are our 2 solutions. Now, once again, I didn't finish sketching out the parabola, so let me do that really quickly. The important thing was we found those points where the 2 equations coincided. They both were at the same place at the same time. And there is our system. And I should probably be checking these each time just to make sure that I haven't messed something up. I have not. So once again, there we go. So we found our second one. Okay, let's start the final problem here. I was trying to wait. There's a bunch of like loud banging and hammering happening outside my house, but I'm hoping that if I just talk loud enough, it'll be okay. I'll check afterwards to see if it's a problem. I'm hoping it's not. But basically, we want to finish. I want to finish. I don't know about you. I don't want to speak for you, but I don't want to keep doing this. I'm ready to finish this project for a little while. Not that it hasn't been a lovely experience, but you know, I'm ready to set this one aside. So here we are. We're on our final one here, 6C. Once again, we've got a parabola in vertex form. We've got a line in point slope form. We are going to solve this system graphically. So we're going to sketch each of these out. But I want to begin just like we did in the past. Let's start with the linear equation, that line right there. So we've got to find or identify 2 pieces here. And again, I can understand you not writing these pieces out. I don't think you have to write out point and slope and then do it that way. I think you can just sort of proceed forward. But basically, just as we've done before in point slope form, we'll see what makes each side equal to 0. That's going to be x equals 1 and y equals 6. And then for our slope, it's going to be the coefficient that's right out there. Now again, it doesn't show us a number, but we know that that's read as positive 1. So we've got a slope of positive 1, and then we're at the point 1, 6. 4, 5, 6. So basically, we need a lot of dots to get down 1 over 1, or up 1 over 1, up 1 over 1. So obviously, this is a lot. We could proceed forward and deal with the vertex before we do all this, but as I've mentioned in earlier episodes, I checked with Miss Nakamura last night about graphing quadratics, and she did recommend over-plotting points. So I'm okay with that. As someone that wrote a book that ended up pretty long, I understand all about over-plotting and doing a little bit more than you necessarily have to give a good picture. So there we go. There is our linear equation. There is y minus 6 equals x minus 1. But now, of course, the real challenge begins. We've got to deal with this parabola. So we're going to focus first on the vertex. And of course, by parabola, I mean this one. It's a quadratic. It's got that squared in there. It's going to produce a U-ish shape of some kind. Something that looks kind of like a U. So what do we got in here? Well, our vertex is going to be the opposite on the inside. So this is x plus 6. So we need x equals negative 6 to make it 0. And then our final value on the outside is negative 7. So we want to plot that vertex. 1, 2, 3, 4, 6, and then negative 7. So 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So there is our vertex. So now, interestingly enough, obviously we are going to mention the direction here. I'm trying to be consistent and sticking with those same processes the entire time. But let me point out here for a second that our parabola, if we want the system to have a solution, cannot possibly be a sad parabola. Because if it did, it wouldn't necessarily intersect the line. Basically, in fact, I'm pretty sure that this one would never intersect the line. So it has to be upward. And of course, based on the fact that our a value is equal to positive 1, this is in fact going to be an upward facing or happy parabola. So basically, if you're wondering why happy, there it is. It's there the whole time. So there it is. So we've got that. Now, of course, all that's left are finding some values, and I'm seeing we're going to have to do a little bit of work to get here. But in that last problem, 6b, we talked about how we can use the built-in symmetry of a parabola to avoid having to do so much computation. Because these can take a long time otherwise. If you're being very careful, obviously you have calculators, but if you're being super careful, it's really time-consuming to plug in lots and lots of x values, especially because you might have to go out quite a ways. So what we're going to do is we're going to pick values, and we're going to just focus on one side first, try to get to an intersection point, and then we'll use symmetry to get the other side. So let's start here. So we are at -6 as our vertex. I'm going to first choose to plug in -7. So again, maybe it'll work, maybe it won't. Let's just see what happens. So if we plug in -7, that's going to be -1, because -7 plus 6 is -1, squared minus 7. That is 1 minus 7, or -6. So we're going to be at the point -7, comma -6. For a second, my mind went, wait, didn't we already graph that? But no, we had -6, -7 before. That's why they call them ordered pairs. So over here, -7, -6 is going to be right there. And then we're going to use symmetry. So again, what does symmetry provide us? Well, it says there's going to be another point right on the opposite side at the same y value. So we're also going to get automatically -5, -6 out of this. So let's plot it. There it is. And again, if you prefer to plug in -5, go for it. But let's try to be a little bit efficient with our time. Why not? So there's our first one. We did -7. That wasn't enough. Let's go to -8. So if we plug in -8, we're going to get -2, because -8 plus 6 is -2. Squared minus 7, that's going to be 4 minus 7, also known as -3. So we're going to have a point at -8, -3. So let's plot -8, -3. -8, -3. Oh, look at that. We got one. Oh, we got a big one. We got -8, -3. We got our first intersection point. So over here, even though I forgot to write the little solutions thing, the answer line basically, we've found already -8, -3 is one of our solutions. That will make our equations true, both true. So now, we need to find one more. But of course, we don't want to keep plugging in lots and lots and lots of numbers, so let's be smart about this. First, we get an automatic point from symmetry. So it was -8. Now we're going to be 2 units away on the other side. That's going to be -4, -3. And again, this obviously doesn't solve our equation, but it's nice to have all those points. We want to have them. But now, based on what we can see from our picture, we can kind of see that our intersection point isn't going to be up here. It's going to be on the other side. So let's just be kind of smart about this. -5, -4, let's try -3. Let's just focus on that for the moment, not worry about the symmetry on the left side the same way. So if we plug in -3, we're going to get -3 plus 6, which is 3, squared minus 7. That's going to be 9 minus 7, or 2. So in other words, we're going to have an intersection point at -3, 2. So there will be a corresponding point based on symmetry, but for the moment, does this do the trick for us? -3, 2, oh heck yes. There is, oops, it erased itself. There is our final intersection point. So we have our second one, -3, 2. There are our solutions. But of course we should wrap this up properly. So I'm going to do 2 things. First, I'm going to use symmetry to get that other point. If you're curious what that point's going to be, it's going to be -9, 2. And then finally, I'm going to sketch out a nice little shape for our parabola. And I hope you like it. Oh, you like the shape. Yeah, you get it. You get it. You get it. More importantly, though, and more wonderful from my end, this is the final video from this particular Essential Skills Quiz model. I'm going to be back working on the second semester or quarter 2 or 3, depending on which course you're in for Math 3, standard or Essential Skills Quiz model. But for the moment, we are completed here. So I didn't do them in order, by the way. Obviously, you have a bunch more skills to look at. But for me, this is the final one that I did. So thank you for watching. Hope these have been informative, sort of reminded you some stuff. This one in particular, talking about point slope form, vertex form, all sorts of graphing stuff. More good practice with tables as well, and we use symmetry a little bit as well. But without further ado, let's call this a day and wrap this puppy up. So thank you for watching. Thank you for watching all of these, presumably, like in a more appropriate order maybe than mine did. But thank you and have a great day.